The last technique we're going to take a look at for integrating is very similar to the substitution that we learned previously, only, well, I refer to it as a double substitution. I'll go through this brief explanation as to where this comes from. Here we have two functions, which I'm going to call for convenience by the letters u and v. Besides that, that's what the formula that we're going to be using utilizes. So, if we do the product rule on the derivative of u times v, we get u times the derivative of v plus v times the derivative of u. Now, I'm simply going to rename some of those things. For example, the derivative of v, I'm just going to call v prime. The derivative of u, we're going to call u prime. Now, we can do that since both of them are with respect to x. So we can rewrite our product rule like this. We're also going to do the integral of both sides with respect to x and do a little bit of renaming. dv is the same thing as v prime dx, and du is the same thing as u prime dx. So we're going to replace the quantities that we just said, and this is what our formula looks like, which is on our formula sheet and which we need to learn how to do. So here's how the process works. We are trying to do the integral of x times e to the x dx. Now let me do a little rambling here to start with. We just learned the substitution technique. If I want to try substitution on this, I would take perhaps u equals x, which means du is equal to a 1 times dx, which means our integral transforms into u times e to the u times du. Well, that's no help whatsoever. That's exactly what we had to begin with. There are other options for choosing the u. I won't continue with this thing because it's all useless. You cannot do this by the substitution technique we learned in chapter 13. So here's how the technique of integration by parts works. We're going to select a portion of this to use for the u, very similar like we did in substitution, and the rest of it needs to be dv. So again, it's like we're doing two substitutions, a u and a v. Now, once we decide what to call u and what to call dv, and again, do you see that whatever we have here and whatever we have here together have to give what we have here. So, using u equals x, we do like we did in substitution. We do the derivative of that. The derivative of x would just be a 1, and so du is equal to a 1 times dx. Now, we haven't done this before in the substitution method. For the dv that we chose, we have to do the integral. The integral of e to the x happens to be e to the x. So, once we have done both of these, we're then ready for our formula. So taking out our formula sheet, here in purple is the integration by parts formula. And from the chart that we just made, we simply need to fill in for the u, for the v again, and then du. Now, if everything works as it should, we should be able to do this integral. Well, the integral of e to the x is e to the x. And so there's our answer. So here in our second example, we're going to start by making us a chart. And you see we have a U and a DU and a V and a DV. Now I've arranged them like this because these top two lines, this top line with the two things on it, that is, should encompass everything beside the integral sign. Now this should be easy to comprehend. The dx part of this should go over here, which for this particular problem only leaves one choice for what goes here. So that's what we will do. We will use the ln of x for the u and the dx for the dv. So again, whatever we put in the top line, we have to do the derivative of the u and the integral of the dv. And then fill in our formula. Here's the u, v, v again, and du. Over here on the right, where the integral sign is, we still need to do that integral. And again, we kind of keep our fingers crossed that we do indeed come out with an integral that we can do. I'll show you when that doesn't happen in the next example. So here, the x's cancel, and we get just the integral of a 1 dx, which is x. And there's our answer. As promised, I'm going to show you what happens when that first process doesn't exactly work like the examples I've shown you. We're going to start by choosing u to be the x squared, dv to be ex dx. Notice again how everything that we have here together is what we have beside the integral sign. That has to be the case. We do the derivative of the u, we do the integral of the dv. We fill that into our formula, which we have on our formula sheet. However, in this example, notice we still don't know how to do that integral. However, this should look familiar because it's practically just like the first example that I used. And we have to do the process again. So we'll choose the u to be 2x, the dv to be e to the x dx. We'll do the derivative of 2x. We'll do the integral of e to the x. And we'll fill in the formula from our formula sheet. Notice how the x squared e to the x just stays the same, and that integral becomes this. Now at this point, we can actually do the integral of 2e to the x. That would be 2e to the x. Now you do want to be careful with the minus signs, because this minus sign, when we put it with the 2x e to the x, is going to give us a negative 2x e to the x. However, this is going to give us a positive 2e to the x. And so we're at the end.